Cancel the denominators. What we're going to talk about here is the next thing you're going to learn is solving rational equations. And what I need you to know is that the main skill, the main thing that you need to know how to do, or at least the only new thing you're learning how to do, is you need to cancel the denominators. Anytime you are solving a rational equation, one of the techniques, one of the ways of solving a rational equation is to cancel the denominators. Okay? I wanted to get that in your head before we go ahead and start. Okay, so I'm going to show you how to solve rational equations. Okay, now it's an equation, which means that we're going to get a solution. That usually means we're getting a number as a solution. Okay, so let me give you an example here. Let's say that we have 20 over x plus 6 is equal to 2x. Okay, now this is a rational equation because it includes a rational expression in the equation. Okay, so now what you're going to do is, in order to approach an equation, a rational equation, at least one that's mostly polynomial or all polynomial except for the rational part, is basically you just want to cancel the denominator. Now, if you recall the way you cancel a denominator in an equation, if you had x over 7 equals 2, the way that you would cancel this denominator is by multiplying by the denominator on both sides, or multiply every term by the denominator. In fact, let's say instead that this was x over 7 plus 3 equals 5, right? Normally, you'd probably subtract 3 here and subtract 3 here, but what I want to show you is, instead of subtracting 3 on both sides, you could actually cancel the denominator first here by multiplying by the denominator, times 7, all the way through the entire equation. So 7 times this, 7 times this, 7 times this. Now, 7 times x over 7, anytime you multiply by a denominator, you can multiply by the numerator or you can cancel the denominator. So here we're going to cancel the denominator, leaving x. We're not going to cancel the denominator and multiply 7 times x. You can't do both. You got to do one or the other. Okay, so here 7 times x over 7 cancels the denominator. We just bring the x down. 7 times 3 is 21. 7 times 5 is 35. And then if you subtract 21 from both sides, you get x equals 14. Now, if we had done that a little differently, instead, if we had subtracted 3 from both sides, we would have had x over 7 equals 2. And then how do we cancel the denominator? We multiply by the denominator. Multiply by 7 on both sides. Cancel, x is equal to 14. It's the same thing. Okay? So if you can do this, you can do that. Now, the only other thing is this, is when solving a rational equation, after you cancel the denominator, you're usually left with an equation that is a quadratic or a cubic function or something where you need to have other algebra skills to be able to solve for x. You'll see what I mean in just a minute. So let's see here. Let's say here, we want to get rid of this denominator. The denominator is x. So we're going to multiply every term by x. We're going to multiply the entire equation by x. Well, here, x times 20 over x, well, that cancels the denominator, and we just carry down the 20. Plus, so that's x times 20 over x, cancels the denominator. X times 6 is 6x. X times 2x is 2x squared. Now, this is a quadratic equation because it has the highest power is 2. It's an x squared. Okay, so the way we solve quadratic equations is we move everything to one side. I want my x squared term to be positive, so I'm going to move this stuff over here. I'm going to subtract 6x from both sides. I'm also going to subtract 20 from both sides. I'm going to cancel here, and we have 0 equals 2x squared minus 6x minus 20. Now, if I look at this quadratic expression here, I notice that there is a common factor there in all these terms. Now, there's no variable because this term does not have a variable. But 2 and 6 and 20 are all divisible by 2. So I can divide out a 2. So this is going to be 0 is equal to 2 times this 2x squared divided by 2 is x squared. Negative 6x divided by 2 is negative 3x. And negative 20 divided by 2 is negative 10. Okay. Now, this quadratic, we got to figure out a way to solve this quadratic. It has to be equal to 0. In order for this whole thing to be equal to 0, the 2 is not going to make it equal 0. The only way you can get 0 in multiplication is to multiply by 0. So 2 is not 0. Therefore, we're not going to include, we're going to kind of ignore the 2. What we really care about is this x squared minus 3x minus 10, which we need to factor. Okay? So, well, this can be factored. You can also use the quadratic formula if you want to, but you have to use some technique, some method for identifying the zeros of this quadratic. Okay? Now, I'm going to use factoring because there are two numbers that multiply to negative 10 but add up to negative 3. And those two numbers are negative 5 and positive 2. So negative 5, positive 2. I'm going to put an x in front of each one of them, put parentheses around. So I've just factored this quadratic. Got a 2 there and a 0. Now the only way this can be true, the only way that this can equal 0 is for either x minus 5 to equal 0 or for x plus 2 to equal 0. So here I would add 5 to both sides and I get x equals 5. Over here I subtract 2 from both sides and I get x equals negative 2. And therefore my solutions to this rational equation is x is either equal to 5 or x is equal to negative 2. There are two solutions. Okay. Now here's the thing. It's something you need to consider is you have to also check these solutions to make sure that they are on the domain. Remember, anytime we deal with rational expressions, we have a domain restriction. In this particular case, x cannot equal 0. So if x cannot equal a number, and then you get that number as one of your solutions, you have to cross it out. It doesn't count. That's called an extraneous solution. Thankfully here we don't have any extraneous solutions. Let's do another example. Let's say we have x plus 7 is equal to negative 12 over x. All right? So we're going to cancel the denominator. The denominator is x, so we're going to multiply through by x. X, so let me bring down the equal sign. X times negative 12 over x, well, that cancels the x, and that gives us negative 12. X times x is x squared. X times 7 is 7x. And so now we have this quadratic again. Okay? Now, we got to set it equal to 0, so we're going to add 12 to both sides. And we're going to have x squared plus 7x plus 12 equals 0. This is factorable. We've got two numbers that multiply to 12 but add up to 7. Positive 4, positive 3. So we're going to have x plus 4 times x plus 3 equals 0. The only way this can happen is if either this one is equal to 0 or this one is equal to 0. So we're going to say x plus 4 equals 0, x plus 3 equals 0, and solve. Here we're going to have x equals negative 4. Here we're going to have x equals negative 3, and there are solutions. Okay? What can x not equal? X cannot equal 0, so we're good. There are no extraneous solutions. Okay? Let's do another example. All right, here's one for you. Why don't you pause the video and try this one on your own. All right, now this one's a little more challenging because we don't just have an x in the denominator, we have an x minus 3. But that's okay. The way you cancel a denominator is by multiplying every term by that denominator. Okay, so we are going to multiply this term by x minus 3. Excuse me. We're going to multiply this term by x minus 3. We're going to multiply this term by x minus 3. And we're going to multiply this term by x minus 3. Okay? So x times x minus 3, well, we have to distribute that. X times x is x squared. X times negative 3 is negative 3x. Now here, if we multiply 3 over x minus 3 times x minus 3, well, when you multiply by the denominator, it cancels the denominator. So we're just going to cancel the denominator, and all we have left is a plus 3. So plus 3 equals 7 times x minus 3. 7 times x is 7x. 7 times negative 3 is negative 21. Now we have a quadratic equation. We've got to move everything to one side. I want the x squared to be positive, so I'm going to move these items over here. I'm going to go minus 7x here, minus 7x here. I'm going to go plus 21 here, plus 21 here. It's going to cancel, and on this side I have 0. Over here, I'm going to bring down the x squared. Negative 3x minus 7x is negative 10x. 3 plus 21 is 24. And now this is factorable. What two numbers multiply to positive 24 but add up to negative 10, negative 6, and negative 4? So I've got an x minus 6 and an x minus 4 equals 0. And now I set each one of these equal to 0. X minus 6 equals 0. X minus 4 equals 0. And I get x equals 6 and x equals 4 as my solutions. Now, what can x not equal? Well, the original here was x minus 3. So x cannot equal 3. But that's good because our solutions are 6 and 4, and so they don't violate the domain restriction. No extraneous solutions. All right, one more example here. Why don't you pause the video and try to solve this one? All right, let's see how well you did here. Let's see. What's the first thing that we have to do? We have to cancel the denominator. How do we cancel a denominator? Multiply by the denominator. So we're going to multiply by x minus 4 here. We're going to multiply by x minus 4 here. And we're going to multiply by x minus 4 here. Now here it's going to cancel the denominator. And we're just going to have a 9. X minus 4 times x, well, x times x is x squared. X times negative 4 is negative 4x. Then we have plus 4. So 4 times x is plus 4x, and 4 times negative 4 is negative 16. Now we're going to subtract 9. It's a quadratic, so we want to set it equal to 0, right? Subtract 9 from both sides, and we get 0 equals x squared. What's negative 4x plus 4x? Well, they cancel each other out, so we don't need those anymore. Negative 16 minus 9 is negative 25. Now we can factor this. This is a special case, a difference of squares. Or we can extract square roots. We can add 25 to both sides and then take the square root of both sides and do plus or minus over here. But I'm going to factor instead. I'm going to say 0 is equal to x plus 5 times x minus 5. It's a special case, a difference of squares, right? Set each one of them equal to 0. X plus 5 equals 0. X minus 5 equals 0, and we get x equals negative 5, and x equals positive 5. And those are our solutions to this rational equation. Okay? So this is a simple case. I made these where these are problems where there's only one denominator, okay, and it's easy to cancel the denominator. The next video that you're going to watch is actually going to have rational expressions where there are equations where there are two rational expressions in the equation, and so you will have two denominators that you have to cancel, which is fine. It just takes a little bit more work, but you can still cancel them. Eventually, you should be able to, though I'm not going to require you to do this, you should be able to solve a rational equation that has 3 denominators or 4 denominators or 5 denominators. But at that point, you may require technology to help you. But this is the very simple case of a rational equation that only has one denominator or one rational expression and only one denominator to cancel. So anyway, I hope this helps. I think you got it. Make sure you do your practice and you should be good to go.